Hello everyone! In this video, we are going to discuss about the sum and number of divisors. So, the number of divisors is the count of how many divisors a number has, denoted as tau n, and the sum of divisors of a number is obtained by adding up all the divisors of the number, denoted as sigma n. Now, let's define these two. For the tau n, we have for a positive integer n, tau n is the number of positive divisors of n. So for example, n is equal to 8. The positive divisors of 8 are 1, 2, 4, and 8. So this means tau of 8 is equal to 4. Now for the sum of divisors, we have sigma n. This is sum of positive divisors of n. In the same example, if I put sigma of 8, this means 1 plus 2 plus 4 plus 8 is equal to 15. So we can see that tau 1 is 1, tau 2 is 2, tau 3 we have 2, tau 4 there are 3 divisors, tau 5 is 2, and tau 6 is 4. For the same list, we can also have sigma 1 is 1, sigma 2 is 3, sigma 3 is valued 4, sigma 4 is 7, sigma 5 is 6, and sigma 6 we have 12. Now from the example, it is very clear that tau n is 2 if n is prime. We can say because n is a prime and prime numbers only have 2 divisors. And sigma n, this would always be n plus 1 if n is prime because there will always be one more. So for further discussions, we have this theorem. If n is equal to p1 to the power of k1 up till pr to the power of kr, then tau n is given by this expression and sigma is given by this expression. So for further examples and proofs, we have Mr. Carl and Miss Janice.
So good day everyone, I am Carlinyo Sarukam and today I'm going to discuss how to find the number of divisor and sum of divisor. The formula of number of divisor is n is equals to P1 exponent 1 times P2 exponent 2 times P3 exponent 3 so exponent n. Tau n is equals to exponent 1 plus 1 times exponent 2 plus 1. So, for example, find the number of the divisor of 5,800. So, in order to find its factor, we need to use the prime factorization method. So 5,800 is 2,900 times 2, and this is 1,450. This is 725 times 2. This is 145 times 5. And this is 29 times 5. The prime factors of 5,800. It could be written as 2 times 2 times 2 times 5 times 5 times 29, or 2 with the exponent of 3 times 5 with the exponent of 2 and 29. So based from the formula in finding the number of divisor, so the formula is E1 plus 1 times E2 plus 1 and so on, En plus. So our exponent 1 is 3. So 3 plus 1 times exponent 2 is 2 plus 1, and our exponent 3 is, it is understandable nga na that there is one exponent, so 1 plus 1. So 3 plus 1 is 4 times 2 plus 1 is 3 times 1 plus 1 is 2. So 4 times 3 times 2 is equals to 24. So the number of divisor of 5,800 is 24. So the formula of sum of divisor is sigma n is equals to I is equal to 1 product n pi exponent I plus 1 minus 1 over pi minus 1. So for example, 5,800. So we all know that the previous example that 5,800, the prime factors of 5,800 is 2 cube times 5 squared times 29 based from the formula. So in finding the sum of divisors, so 2 pi, so 2, and then exponent 3 plus 1 minus 1 over pi, pi is 2 minus 1 times 5, the exponent of 5 is 2 plus 1 minus 1 over 5 minus 1 times 29, exponent of 29 is 1 plus 1 minus 1 over 29 minus 1. So 2, the 3 plus 1, so 4 minus 1 over 2 minus 1 is 1 times 5, so 2 plus 1 is 3 minus 1 over 4 times 29 plus 1 plus 1 is 2 minus 1 over 28. 2 with the exponent of 4 minus 1 over 1 is 15. 5 cube minus 1 over 4 is 31 times 29 squared minus 1 over 28 is 30. So the sum of divisor of 5,800 is 1,000. 13,950, and this is the sum of divisor.
So, good day everyone. This is in continuation of our topic, which is the sum of divisor and number of divisor functions. So, for this moment, we will be dealing some real-world situations or scenarios wherein we are going to apply these concepts. Now, before going on to our examples, I have here some important reminders about the two functions. So, each function uses different formulas as indicated, and both functions rely on the prime factorization method of the number n to determine the divisors and calculate the sum. So, the prime factors denoted by P sub j and their multiplicities denoted by A sub j play a crucial role in each of the formulas. Now for our first example, I have here a situation that says a project has a total budget of $600,000. The project manager, Ms. Jean, needs to allocate the budget to various sub-projects. So each sub-project must receive an amount in whole dollars, and the goal is to distribute the budget in an optimal way considering the constraints. So we write down our solution. The first step that we need to do is to determine the factors of the total budget by prime factorization. So remember that the total budget stated is $600,000. So getting the prime factors of 600,000, we will have 600,000 is equal to 2 raised to 6 times 3 raised to 1 times 5 raised to 5. Now, after we get the prime factors, we will now apply the number of divisors function using the formula I just have displayed a while ago to determine the number of ways to distribute the budget. So, from the prime factorization that we have, the number of divisors, tau of 600,000 is given by the quantity 6 plus 1 times the quantity 1 plus 1 times the quantity 5 plus 1. We have 6, 1, and 5 respectively because our prime factors 2, 3, and 5 have multiplicities like 6, 1, and 5 respectively. And performing the necessary operations, we will have a product of 84. So, tau of 600,000 is equal to 84, which means there are 84 different ways for the project manager, Ms. Jean, to allocate the budget to the sub-projects, each amounting to a whole number of dollars. After that, we will now then use the sum of divisor functions to calculate and find the total sum of all possible allocations. So again, from the prime factorization that we have, the sum of the divisors or the sum of divisors sigma of 600,000 is given by using this formula over here. We will just have to substitute the respective values for P sub j and A sub j. So we have here, we just have to substitute, and then we will get this, and then performing the necessary operations and simplifying the terms, we will get 127 times 4 times 3,906, which will give us a product of 1,984,248. So the total sum of all possible allocations is 1,984,248. So in this scenario, the number of divisors function help us to determine the number of ways that the budget can be allocated to the sub-projects, while the sum of divisors function helped us to calculate the total sum of all possible allocations. So these functions really provided us the insights into the optimization of the resources for planning a project. Now, for our second example, we have here another situation. Teacher Babes has a collection of 60 books. She wants to arrange the books on the shelves in a rectangular grid. So what are the different ways that Teacher Babes can organize the books, and what is the total number of arrangements? So writing down our solution, the first thing that we need to do is to determine the prime factors of 60, which means a collection of 60 books. So the prime factor of 60 are given by 60 equals 2 raised to 2 times 3 raised to 1 times 5 raised to 1. After that, we will then apply the number of divisors function denoted by tau of n to find the number of ways the books can be arranged. So from the prime factorization that we have, the number of divisors, tau of 60, is given by the quantity 2 plus 1 times the quantity 1 plus 1 times the quantity 1 plus 1, which will give us a product of 12, which means there are 12 different ways for Teacher Babes to organize all of her books. And then we list all the divisors of 60. As you can see, we have the divisors 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So this is because we will pair up these divisors since we are dealing with a geometric arrangement. So as indicated, as we pair up, we have the pair of 1 times 60 equals 60, 2 times 30 equals 60, 3 times 20 equals 60, and so on and so forth until we reach the pair 6 times 10 equals 60. So we have here 6 pairs of possible dimensions for the rectangular arrangements of the 60 books on the shelves. Then we get the sum of the total number of ways to arrange the books, in which it is equal to 6 pairs. That is why we will have 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is equal to 21. Then we multiply it by 2 to account the symmetric arrangement. So we have here 21 times 2 equals 42. So in the context of arranging the books, we are considering the divisors of 60 as potential dimensions for the rectangular arrangement. So the sum of 1, 2, 3, 4, 5, and 6 is clearly the sum of all of the divisors that are used as the number of rows in each arrangement. So it is not the sum of divisors of 60. Rather, it's the sum of the possible numbers of rows in each arrangement. So to summarize, Teacher Babes has 42 different ways to arrange the 60 books on the shelves in a rectangular grid, and each arrangement represents a different geometric layout for the bookshelves. So Overall, the sum and number of divisors functions are applied to certain real-world scenarios, particularly in optimizing resource distribution, cryptography, combinatorics, where it is applied in counting arrangements and combinations, in organizing items, or arranging objects in geometric patterns. So these functions derive from the mathematical properties of numbers, finds practical uses in diverse fields, contributing to efficient resource management and structure organization in the real setting. And that concludes our discussion for our topic on multiplicative functions, the sum and number of divisor functions. So I want you to try and answer this given problem here. So thank you for watching.